It came from the dark, without warning. And within the first seconds of observation, scientists realized they had no explanation for what they were seeing. On July 1st, 2025, an automated telescope in Chile caught a point of light in its lens that should not have existed. Not a comet, not an asteroid. An object moving too fast. So fast that no gravitational pull from the sun could hold it. It came from interstellar space, and this was already the third time. But it was the third one that broke every explanation. Because this object had something the previous ones did not. It had behavior, not chaotic, directed. It changed speed. It flew precisely toward a destination that, according to every calculation, it should not have been able to reach. And then, after passing Jupiter, it disappeared. Forever. They called it 3I/Atlas, and it left behind more questions than it answered. Humanity had two chances to understand what comes to us from interstellar space. The first, in 2017. An object called Oumuamua, a shape that doesn't exist in nature. Elongated, flat, like nothing we had ever cataloged. Acceleration with no visible source, no tail, no gas jets, no explanation. It crossed the solar system in a matter of weeks and vanished before scientists could even agree on what it was. The second, in 2019. 2I/Borisov, an ordinary comet from another star system, nothing supernatural. Scientists exhaled. Maybe Oumuamua was just a strange piece of ice. These things happen. On July 1st, 2025, the third one arrived. Atlas, an automated asteroid detection system in Chile, picked up an object 670 million kilometers from the sun, already inside Jupiter's orbit, already active, with a coma, with a dust tail, and already moving on a hyperbolic trajectory with an eccentricity of 6.14, a number that means only one thing. This did not come from here. Speed at detection, 221,000 kilometers per hour. At closest approach to the sun, 246,000 kilometers per hour. It was officially named 3I/Atlas, the third interstellar object in the history of observation. And within days it became clear, it didn't fit either of the two previous categories. Not silent and strange, like Oumuamua. Not calm and familiar, like Borisov. Something in between. And it was exactly that in-between that turned out to be the most unsettling thing of all. Over the following months, it was observed simultaneously by Hubble, James Webb, the Rubin Observatory, ESA spacecraft near Jupiter, and hundreds of observatories around the world. No interstellar object in history had ever received this level of attention, and none had left so many unanswered questions. Let's start with what can actually be measured. The core, somewhere between 440 meters and 5.6 kilometers across. A more precise number is impossible to give. The object is wrapped in a dust cloud 25,000 kilometers wide. Its mass, according to Avi Loeb at Harvard, no less than 33 billion tons. To put that in perspective, that's thousands of times more massive than scientists would expect from a random interstellar rock drifting into the inner solar system once a decade. That alone is a statistical anomaly. But then things got strange. Telescopes detected non-gravitational acceleration, a deviation from the path that gravity alone would dictate. Comets can do this. Sublimating ice releases gas and pushes the nucleus like a thruster. But with 3I/Atlas, the acceleration behaved differently. Too focused, too directional. The jet, the stream of ejected material, was 10 times longer than it was wide. No known comet has ever shown anything like it. The chemical composition didn't add up either. In the gas cloud, anomalously high levels of nickel. The nickel-to-cyanide ratio, orders of magnitude above any known comet. Deuterium, heavy hydrogen, 30 times above normal. This is the signature of an object that formed in conditions nothing like our solar system. Kinematic age, somewhere between 3 and 11 billion years. Older than Earth. And then there's one more detail. One that's hard to let go of. 3 I/Atlas arrived from roughly the same direction as the WOW signal of 1977. The only radio signal in history that has never received a natural explanation. The probability of that being coincidence, around 0.6%. That's not proof, it's just a number that doesn't leave you alone. On October 29, 2025, 3 I/Atlas reached perihelion. Then it began to leave. On March 16, 2026, it passed Jupiter at a distance of 53.6 million kilometers. That number deserves a pause. Jupiter's hill radius, the boundary where the giant's gravity overtakes the sun's, is 53.5 million kilometers. The difference, 100,000 kilometers. Less than 0.2%. Avi Loeb calculated, if the object had wanted to enter orbit around one of Jupiter's moons with minimum energy cost, it would have had to pass through exactly this point. The odds of that being random, less than 1 in 25,000. ESA spacecraft watched the flyby from 60 million kilometers away. The photos arrived. A comet, a coma, 2 tails, nothing that closed the question. After Jupiter, it left the solar system, permanently. 5 radio telescopes on 3 continents listened until the very end. Result: silence. But absence of signal is not an answer. It's just absence of signal. NASA's official position: a comet from another star system, a natural object. That's an honest answer. And at the same time, an incomplete one. Because it doesn't explain the mass, doesn't explain the jet, doesn't explain the chemistry, doesn't explain the precision of the Jupiter flyby. We watched, we photographed, but we didn't fly. Not one probe was sent. Loeb said it plainly. We missed the chance to touch an object from another star system. The next one may never come. Right now, 3 I/Atlas is somewhere between Saturn and Uranus, moving at 60 kilometers per second, twice as fast as our fastest rockets. We cannot catch it. 22 documented anomalies. Not one disproven. Not one fully explained. It was here. It passed us. And it left. In silence. 3 I/Atlas has gone into the dark. But the dark is not empty. Subscribe to Star Voyager. We watch where others don't look.